In this video, we're going to learn how to take a Lewis structure and figure out its molecular geometry or molecular shape. And we're going to use a process called VSEPR theory, so VSEPR. This table here is going to be very helpful for you, so I encourage you to have it handy. Take a screenshot if you want. I will also try to remember to post it to Canvas for you. So what this is going to do is once you have a correct Lewis structure, which is step one, you're going to count the number of bonding groups that your molecule has, as well as the number of lone pairs that your molecule has. By doing that, you will then be able to match up and determine what its molecular shape will be. So the whole point of VSEPR theory is that our atoms and our electrons want to be as far apart from each other as possible. So they're going to move to a position that they're mathematically as far apart from each other as possible. And that's how we come up with these shapes. So let's look at these. So tetrahedral, we've got 4 bonds to the central atom. So that's 4 bonding groups. There's no lone pairs. And this lone pair count is on the outer atoms only. And that is one thing that really trips people up, is they want to count lone pairs on the exterior atoms. Do not do that. And we'll see an example in the next one here. So this next one, we have 3 bonds. So notice that I count the double bond as 1, just like I count the single bonds as 1. So that's another trick, okay? So that's 3 bonding groups. And then if we look, the carbon atom has no lone pairs, right? The oxygen does, but I don't count the ones on the outer atoms. I'm only counting lone pairs on the middle atom. So that count is 0. So this is what we call a trigonal planar geometry. And the names go along with what the shape actually looks like, which is something that you're also going to want to understand. So tetrahedral, you've got those 4 atoms kind of on the outer edge of a sphere, as far apart from each other as possible. Trigonal planar, the trigonal part, you can think about having a triangle for your outer atoms, and it's planar because everything is flat on the paper. It's planar. If we compare that to the next one where we have trigonal pyramidal, so we have 3 atoms that kind of form a triangle, those 3 outer atoms, but now it looks like a pyramid. So overall, we have kind of a pyramid shape. So to get this molecular shape, we're going to have 3 bonds, which we have, plus a lone pair. So 3 bonding groups and 1 lone pair is going to give you trigonal pyramidal. If you have 2 bonding groups, to get 2 things as far apart from each other as possible, it's going to be linear. And this is when there are no lone pairs, again, on that middle atom. If you have 2 bonding groups and now you have either 1 or 2 lone pairs on the middle atom, both of these we call bent. Our textbook uses the term angular, which is what you're going to want to use for your homework. I have a tendency to use bent. That's what I'm familiar with. So just make sure that you understand that these are the same thing. So whether you have 1 lone pair or 2 lone pairs, if you've got that in combination with 2 bonding groups, the molecular geometry will be bent. So let's look at a few examples. We're going to figure out the shape, molecular geometry for each of these. So notice we're just given a formula. So when you're given a formula, the first thing you need to do is draw the Lewis structure. I'm going to give you the Lewis structure for these. If you need to do more practice with Lewis structures, I encourage you to go back and watch that video again and do more practice. So here's the Lewis structure for HCN. Again, try yourself and see if you come up with a structure, but here's your answer. So I'm going to see that I have 2 bonding groups. Remember, the triple bond counts as 1, just like the single bond does. So 2 bonding groups is going to be one of these 3 options. I see that I do not have any lone pairs on carbon. I don't care about the ones out on nitrogen, so I've got 0 lone pairs. So that ends up matching up with the linear geometry. Okay, so those 3 atoms are in a straight line, much like I drew them. NH3. NH3 has this Lewis structure. So if I look for my groups here, I will see I have 1, 2, 3 bonding groups. So it's going to be one of these 2 options, one of the trigonal options. And then I also have a lone pair. So if I look for 3 bonding groups and 1 lone pair, this is going to be trigonal pyramidal. And this is actually the example that's given here as NH3. The last problem here, we have O3. O3 looks like this. So if we count up our bonding groups, we have 2. So the double bond counts as 1. The single bond counts as 1. So again, we're down here in the bottom option of 2 bonding groups. This time we do have a lone pair on the middle atom. I don't count all of them on the outside, just on the middle. So 2 bonding groups and 1 lone pair is going to have a bent geometry. So those atoms actually look more like this rather than in a straight line.